Now that we have a nice picture ready to go, one of the requirements we have this week is to animate it in some interesting way. Now, we'll have a demo on different options you can do in animation. Let's talk about the foundation of what animation is, and then you can jump up to whatever level of animation you want to try. The important thing within every animation, and they're all done with the same foundation we're going to show here, is we have to add in the idea of time. So I'm going to draw now, I'm going to wait some amount of time, then I'm going to make a change to my drawing. I'm going to draw over my drawing in some way. I'm going to erase it and do it all over again in a slightly different way. And so whether we're talking about a super fancy video game, 3D graphics, everything else like that, or just simple, what we're going to do, animation, maybe even just something flashing on and off, it all starts from here. And inside of Swing, we have a component called the timer object that'll help us go through this. The timer object, basically, we set something that's going to go off and redraw based off of some interval. In this case, I'm setting a 1 second interval, 1,000 milliseconds. It's 1 hertz, 1 frame per second, if you will. So if you wanted to do traditional movie stuff, 24 frames per second, it'd be 1,000 divided by 24, whatever that number's, 40 some frames or whatever, 47 milliseconds that would go in between. That would draw pretty quickly, and that's really faster than the human can process. Now, I mean, some games at this point are running 60 hertz, 60 times a second, very, very fast. For our sake, it's a number you can play with, but again, start pretty big. It's gonna help you to be able to see one at a time how it's clicking through this stuff. So start pretty big, and then we'll speed it up from there if you need. But this timer object is the one that makes it happen. Now, responding to the timer, every time the timer clicks, we need something that's going to update the animation, and that's going to be an action listener. Now, the action listener, you're going to find out later on, is the same action listener that listens when a button gets pressed. So it's all kind of tied together. So when in response to a timer, I could also be responding to a button. If you have a really complicated animation, you could say press button, press button, press button, instead of automatically clicking the timer. But for now, the timer is going to work perfectly fine for what we're going to do. And so the timer, it's going to click an action listener, which has an action perform method. And this is an interface, the action listener. We're implementing an interface now. And then the action perform method is implemented to be able to respond to that event, saying, hey, it's next thing, what's going to happen. So what do? I mean, I draw the picture. Well, I'm going to draw the picture again. I'm going to change something. There might be new user inputs. So if I'm doing a video game, the user might press up, down, left, right. They might fire their lasers or whatever they're going to be doing in their game. There could just be some changes over time, and that's what we're going to be doing. So maybe we wait 3 seconds and then we turn something on, then wait 2 seconds and turn something off, then wait 3 more seconds and turn something else on. The classic neon blinking sign that's out there. Or we can move something across the screen. We could say, hey, it's going to move from left to right across the screen. It might be slightly time, but it might be positional as well. When I get all the way to the right side of the screen, I'm going to jump back to the left side of the screen. So the point is that something should be changing over time. Something should be moving. Something should be drawn differently. Something should start showing. Something should stop showing. I should do all of those state changes and then redraw my display after that. So inside of my action listener then, it's going to be separate from the things that's happening in my picture. And in this case, I'm actually building a separate class for it. So I have my picture that I'm drawing, and then I have some sort of count. In this case, I'm choosing a cycle. And what I'm doing is I'm treating my picture as like a component that is a bunch of switches on it. So think of it like your Christmas lights. Instead of when you automatically plug them in, they start flashing, jingling, moving around. Let's say that there's a little control panel that you could set in your hand. You could turn it on, turn it off, change the colors, make them cycle down, whatever you want to do that. That's what I've built here. So I have a picture with the ability to change a color. I have a picture with the ability to swap something on the display. And then every 10 counts, we'll talk about that in a second, I'm going to flash something. And then I need to repaint it. So I'm going to change the state, and then this repaint method is what I call to make the paint method get called again and change the display. So every single time the timer clicks, the action performed is called, I'm going to change the color, I'm going to swap the display. And then every 10th time, I'm going to flash something. Now, what this 10th time is this is a mod operator. So if you think count divided by 10, so 0 divided by 10 is 0. 1 divided by 10 is 0. 2 divided by 10 is 0. 3 divided by 10 is 0, so on and so forth, up until you get to 10. 10 divided by 10 is equal to 1. Because remember, this is integer math. It's not, so 5 divided by 10 is 0.5, but it's integer, so it's 0. What the percentage here is what's called the mod operator. So 0 divided by 10 is 0. 10 divided by 10 is 1. 20 divided by 10 is 2. But 10 mod 10 is 0. 10 mod 11 is 1. It's the remainder. 12 mod 10 is 2. 13 mod 10 is 3. 20 mod 10 is 0. 21 mod 10 is 1. 22 mod 10 is 2. So by using this, I essentially count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. 1, 2, 3, 4, so on and so forth. That's the idea of the mod operator. You could do the same thing with the 8 count if you wanted to run a little faster. You could do the same thing with a 20 count if you want to run a little slower. And we'll see this in our demo a little bit. So one warning while you're doing drawing in Java. When you draw something in Java, it persists. And when you draw the next thing, it draws over it. So think of it like oil paints. Every time you dip your brush in paint, you paint over it, that oil sticks. Just because I come back the next day doesn't mean I start with a fresh canvas. So if you want to start with a clean palette every time, you have to wipe it out. You can use the clear rect method or just draw a color you want over the top of it. My default, just draw a big black or white or whatever background color I want to rectangle and then draw everything over again. Really advanced animation will actually just tweak things as they draw and move across the screen because you can do some algorithms to make that happen. But the simplest is just wipe it out, draw it all over again every single frame. It's slower, but our computers today should be fast enough we're not even going to realize it at the rate we're going to be drawing. So as we put it all together, you don't need to build it this way, but my recommendation, the way to build it, is you're going to build some class that represents your logo. And it's going to have some sort of state that we're going to add into it. And as you go through and you have your animator and action performed, I'm going to be calling some method over there to set or change or update the state. And then I'm going to have a timer object that's going to kick off my animator over and over and over again. And then a window or frame that's going to hold the whole thing together. So I just want to give you the design view of this thing. I'm probably going to build at least 4 classes. I'm going to have a window or frame that holds inside of it a logo. And then that main method within the window frame is going to build an instance of the animator, which is going to then get kicked off by the timer. And then that animator is going to point to the logo and update it. So I'm going to need these classes and then a lot of creativity and a little bit of patience, and then animation comes together and it should be kind of fun. So the graphics that we've done so far, we're going to update in our demo and make them dynamic, and then we're going to animate them. And that's really all it comes down to at this point. Past that, it's implementation. It's a lot of details, but conceptually that's all we have to worry about for now. So listen to the live chat. We'll talk a little bit more about the expectations for exactly what you should be drawing. But at the minimum, we want to have some time going on and things turning on and off and changing on the screen. There'll be a point where we get all that done, and then we might do something a little bit more advanced. But that's all that's really being asked for. You don't have to do interactivity. You don't have to do motion of things. You don't have to do that if you're not ready for it. But for some of you, this is a ridiculously fun topic, and I want you to have fun with it. It's my favorite exercise of the whole Java classes, every single one of them, and so I'm looking forward to your input coming in. Be creative. Ask questions as you have them, but just understand the expectations are not sky high outside of just looking forward to your creativity. Good luck. I hope you have fun, and I'll see you here in the demo in just a second.